Hello my friends, and welcome to this new practical activity on this time, the Kernel SVM model. So please follow me into part 3, classification, to implement the Kernel SVM model. And as usual, we're going to start with Python, and here we are with our two files. The first one that contains the whole implementation of the Kernel SVM model in the IPyNB format, and the second one, the dataset, that same dataset on which we trained and will train all the classification models of this part. So let's have a quick look at it again. This dataset contains some information of 400 customers represented by each row here. So each row corresponds to a customer, and for each of these customers, well, we have the age, which is the first feature, the estimated salary, which is the second feature, and the dependent variable purchased, which tells whether or not they bought no or yes a previous SUV. All right, and so in our practical activities of this part 3 classification, we build several classification models to understand the correlations between these two features here and this dependent variable purchased in order to predict which future customers will buy brand new luxury SUV that is advertised on social networks. All right, so still the same story. And now, well, let's begin our Kernel SVM implementation. I'm going to open it with Google Collaboratory, but you have the choice to open it with Jupyter Notebook as well. Choose your favorite. And now it is opening the notebook, loading it, laying it out, and there we go. Welcome to the Kernel SVM implementation. All right, and of course it results from the exact same classification template which we made in the first section of this part, logistic regression. Indeed, when we built the logistic regression model, we made at the same time a great classification template which allows us to only change one cell when building another classification model, which is exactly, the cell where we build and train this classification model on the training set. So this cell is the only one we have to modify here. However, this notebook is in read-only mode, so in order to modify this cell to build a Kernel SVM model, we have to indeed click File here in order to create a copy of this notebook. And to do this, you just need to click Save a copy in Drive. This will create a copy of this notebook, and in a second, you'll have it opened on your machine. All right, so I'm going to put everything in that order. All right. And now this is our copy, and so inside the only thing we have to re-implement is indeed that cell where we build and train the Kernel SVM model on the training set. So let's not look at it, let's put it in the trash, and now let's re-implement it from scratch. All right, perfect. So it's actually super easy. We can even do it even more efficiently than the usual way when we went to the Scikit-learn API, then got the name of the function, because as I explained in the previous section when building the SVM model, the classic one, well, the way we built it was actually to, build an object of this class, SVC, and then choose a linear kernel. And now, actually, we're about to do the same. We're about to use the same class to build this Kernel SVM objects, but this time instead of choosing a linear kernel, we will choose a non-linear one, and that's the best example of it, the most commonly used. It is the RBF radial basis function kernel. And you also have some other ones like the polynomial kernel or the sigmoid kernel, but really this one is the best option to start with. And that's the one we'll choose for our Kernel SVM implementation, as you might have guessed. And therefore, remember how I also want to train you on how to juggle with the different tools of your machine learning toolkit, the data preprocessing toolkit or the regression toolkit, or even now the classification toolkit containing all your classification models. The most efficient way now to build this Kernel SVM model is just to go back to our SVM implementation, then find that cell where we built the SVM, and indeed, since we built that SVM with the same class SVC, but choosing a linear kernel, well now, as simple as that, in order to build our Kernel SVM, we just need to take this code cell and paste it right here in a new code cell, and then guess what? Just change that kernel parameter. All right? And as we said, this time we're not using a linear kernel, we're going to use an RBF kernel, the radial basis function, which was explained in the intuition lectures. And there you go, my friend, that implementation is over. You see how I'm doing all these templates to make you as most efficient as possible. Well, that's what I mean. Now we can juggle between our different codes, different tools of machine learning, and we can build new models in Flashlight. And that's what we just did with Kernel SVM. All right, so basically we're done, we're ready. So the next natural step is to upload the dataset inside the notebook. And to do this, you need to click this folder button here. Then your notebook will be connecting to a runtime to enable file browsing. Still the same story. In a few seconds, we should be able to see the upload button. Perfect. There we go. And so now we're going to click it and we will directly get access to social network ads if you were here in the SVM section. But let me show you the path once again. So please find first your whole machine learning AZ folder. Then please go to part 3. Then section 17 kernel SVM, then Python, and then social network ads.csv. Perfect, it will upload the dataset inside the notebook. And now we can run everything by clicking runtime here and then run all.